take note of that while I set up my. Okay, I'm done setting up. So please listen, so that when I'm writing the next set of things, you can copy from the beginning. Just listen first. Lily, listen. So now, we are looking at existence of limits. The fact that we can easily substitute does not mean that functions limit exist. As a matter of fact, one of the problems I gave you last week, the limit does not exist. I don't know if anybody noticed that. I gave you, I think in particular the last question. But by the time you do what I ask you to do, you are going to end up with denominator is equal to 0. It means the limit does not exist. Give me the name of the function. Okay, hold on. 2x squared, yes? Minus x plus 1. 5x plus 3. Okay. As x tends to what? Infinity. Okay, as x tends to infinity. We will see why your answer was still infinity yesterday. Either positive or negative infinity, it means it does not exist. But as x tends to infinity, we run into problem. So when does a limit exist? We can investigate deeper, okay? And that's what we want to do. If you are going to do, like Lillian has indicated, maths later, these are the things you will play with in your first few lessons in analysis in class. Okay, so you might want to really like take note of them. Now, you see, there's something we call one-sided limits. We've never discussed that until now, because students don't need to know. It's like telling a 3-year-old how ham and what do you eat? Like the burger with ham in it, how it is made. Now you have to tell the kid about bakery, where the bread is made. You have to tell the kid about the animal that was put inside. Like a 3-year-old does not need to know about that. All he or she cares about is this thing tastes good, right? Oh, my mom is going to take me to 7-Eleven. I'm going to give them my card and I'm going to get something in return. They are used to that routine. So until now, you don't need to know all the nitty-gritty of limits, but now you are ready to learn it. That is why we can introduce you to something called the one-sided limit. Okay? Limit is observed actually from both sides. The only reason you are able to get the limit of a function is because the two-sided limit coincide at that value. Because you can look at the limit from this direction or from this direction. If they are different, so which one do you choose? Oh, when you only say when x approaches a. What if x approaches a from here and you still don't get the same thing when x approaches a from here? So which one do you choose? So the limit only exists if both-sided limits coincide. By coincide, I mean they are the same value. Am I making sense? So these two symbols, this and this one and this one, are called one-sided limits. When you see minus, it means from below. When you see plus, it means from above. It means from that direction, from this direction. Does that make sense? So this symbol, rather, this is how you read it. Limit of f of x as x approaches a from below. Or as x tends to a from below. But you know, when you use the word tends to and you say from below, it doesn't seem like you're speaking correct English. So that's why we can use the word approach. It's better. Understand? So these two are called one-sided limits. Why are they important? The only condition for the limit of a function to exist as that variable approaches a value is when the two one-sided limits, there are two of them now, from below and above, when they actually tend to the same number. Am I making sense? Now, let's look at this. The only reason the limit of 1 over x exists as x tends to 1. Remember, when x tends to 1, the limit tends to what? 2. That tends to 1 also. Look at that function. Let's look at y is equal to 1.
No, it's 0.
Oh, when x tends to 1, this is 1, right? Okay. The limit of that 1 over x as x tends to 1 is 1. So why am I not saying
Wait,
like
what?
1?
Huh? No, it should be 0.
Limit of 1 over x
Yeah.
when x tends to 1. You don't understand what I mean?
I think he's looking at the top. Is that
Yeah.
1? That's why he's looking at the
You're thinking of the
Because as x gets super big, then it's gonna become a
Move
really
to
large
0.
fraction.
Yeah, maybe I used the wrong example. I'm trying to use this one too. So yeah.
Or this is 0.
As x tends to 1, yes, 1. 1 over x to 10 to 1.
Oh, wow.
I'm just trying to show you in the graph. Why is it not the function?
As x tends to 1.
Isn't it the graph
Right,
of
yeah.
this function?
top.
So what is wrong? This calculation is alright.
Wait, so as x approaches 1. No, wait, that's right.
When
that's
x
right.
approaches 1.
That's right.
Oh yeah. I'm looking at it the wrong way. I'm sorry. I'm looking at it the wrong way. Okay. Okay. So now look at this. X value is coming from different directions, right? So let's say x is coming from below. X is coming from here. Okay? When x is coming closer, you have no business with this part. When x is coming closer, then this is going to be coming. So the graph is coming from 0, from nowhere, we don't know. No, when x is coming from below, the function, x is on this line, black line, okay? The function is this blue line, okay? This blue line is moving close to but I can't see y is equal to 1.
Look from the part on that side.
When x tends to this from below, this graph is moving close to what? Y is equal to 1. The value is tending to 1. That's my y is equal to 1. Gosh. Come on. Y equals 1. Okay. I don't know why am I confused.
Wait, what are you trying to find?
I'm trying to trace how it's getting close to that value 1, which is y is equal to 1. And when y is equal to 1,
It's only
Oh,
it's only the top part.
it's only the top part.
Yeah. It's only the top right part.
Because this one coming from this direction, this one coming from this direction,
That's it.
from below, it's even it even goes beyond that.
But when it's going to 1, the line is pointed upward. The line is also
So at that one, yeah, maybe this is not a perfect example that I should have used. This is not a perfect example that I should have used. I'm trying to get the geometric picture of this and try to tell you why it doesn't exist at the point. Now look at this. Let me try to, hopefully you can get the idea. But it is always better to view it from the picture. It's always better to view it from the picture. Look at this further instruction here. No, not this one. This is not relevant. When x tends to 1 from above, coming from this direction, and it's getting close to 1, my y is getting close to what? Oh, y is becoming large. Oh no, this is not the perfect example I wanted to use.
Or maybe you can watch the self.
No, but oh yeah, okay, I play that. Maybe there's something, clue I'm missing here. Let me play that, but I want to picture it rather than telling you to memorize a concept or an idea.
In the previous example, we found the limit of a function by observing the value of the function as x approaches a particular value. For the limit of a function f to exist at x equals a, there are 3 conditions that must be satisfied. As x approaches a from the left, f needs to approach a particular finite value. In other words, the limit of f as x tends to a from the left exists. As x approaches a from the right, f needs to approach a particular finite value. In other words, the limit of f as x tends to a from the right exists. Finally, the limit of f as x tends to a from the left must equal the limit of f as x tends to a from the right. We summarize these conditions in one statement. In this example, we consider the function 1 over x. In part A, we want to find the limit of the function as x tends to 1. As x tends to 1 from the right, 1 over x tends to 1. As x tends to 1 from the left, 1 over x also tends to 1.
Still to
These limits exist and are equal, so the limit as x tends to 1 of 1 over x exists and is equal to 1. We say that 1 over x converges to 1 as x tends to 1. In part B,
that's exactly what I'm trying to avoid. I needed to picture it in the graph. Okay, just listen first.
Since the denominator is x, the expression is undefined when x equals 0. However, by itself, this does not mean that the limit of the function as x tends to 0 will be undefined. Consider the graph of 1 over x. There is a break at x equals 0. As x tends to 0 from the left, 1 over x tends to minus infinity. As x tends to 0 from the right, 1 over x tends to plus infinity. The limits of the function as x tends to 0 from the left and right do not exist.
Let's see
So
what that means.
the limit as x tends to 0 of 1 over x also does not exist. We
Let's see
say
what that
that
means.
1 over x diverges as x tends to 0.
It doesn't seem clear,
So
right?
this means
Okay, I've
okay.
seen what I missed. Listen, this is what I'm missing. I was thinking too much. I was thinking too much. When x tends to 1 from below, come on. When x tends to 1 from here, so it's going to be coming this way, right? On this line, what happened to the blue line? The blue line is going to follow you from here, right? Then, but when you come here, it's going to jump. So you have no choice but to consider the blue line at the top, right? You have no choice but to consider the blue line at the top. So by the time x moves close to 1, you see the blue line is coming now from the top, right? And when x is moving close to 1 here, the blue line is also approaching y is equal to 1, which is the black line. That's the explanation. I don't know how that disappeared from my brain. I knew I had it, and it just went away. Again, when x approaches from negative infinity, let me try to make this smaller, but I needed that 1 to be seen. Label. No. Steps. Step 1. Okay. When x approaches from negative infinity to 1, right? 1 is somewhere here. 1 is here. Okay? So x is coming this way on this line, and this is the partner, the graph. The graph is going this way, and here they have to say goodbye. Okay? Then it appears from here. So this is moving, this is coming down. So as this is moving towards the green, this is also moving towards the green, which is line y. This is y is equal to 1. That's why I put this line there. Are you with me? If it is coming from the other direction, as this is coming, the blue line is also coming. As this is moving close to 1, this is also moving close to y is equal to 1. So either way, this blue line approaches 1. Again, x is moving on this x-axis. The limit is a y value, which means it's moving on this blue line. So you are going to count these values. Am I making sense? The y values. So it looks like it's going down, right? But when x gets here, it disappears because it stops. This one stops. But the blue line is continuous, right? It continues from here. Okay? It continues from here. I used the word wrongly. It's not the continuous like that. It continues from here. So it disappears from here, it appears from here. X is still trying to approach 1. And yes, the blue line is also moving close to y is equal to 1. So it's coming to y is equal to 1 from above here. Are you with me? Then if x is coming from the other direction, so this is one of the sides of the limit, right? If x is coming from this direction, the blue line is coming down from below, sort of, getting close to 1 also. So in any case, it approaches, they approach the same value. Then they coincide. I have put all these 3 conditions mentioned in that audio together here. The first thing is, both of them must exist definitely. Like if this one is infinity and this one is 0, it means one of them don't exist. So it's not possible. The next thing is both of them must be the same value. And whatever value both of them become is your limit eventually. Understand? So for the case of when it approaches 0, you can see that clearly also even from the graph. As x approaches 0 from here, y is approaching what? Negative infinity. So this is getting close to 0. This is going down. It doesn't cross, so this does not take over. And when this is coming from here, this is going up, positive infinity. So you can see the first limit is up, the second limit is down. Both of them don't even meet. None of them even exist. Like infinity is not something that exists. That's why you have that other example like that. Does that make sense? When x approaches this, positive infinity, approaches this, negative infinity, you can see 0 from above, it just diverge. Oh, 0 from below, another one. So then you can now say, oh, since these two do not coincide, then the limit does not exist. In this case, since these two coincide, the limit exists. This is not a short explanation I would want you to give. I want you to write the since. Oh, since the first limit, maybe I write a better way that I want you to write it down. And this is all about that. Now, let's look at some of the homework that, not homework, practice exercise or whatever you want to call it. Look at this one. Let's say we are interested in the limit of this function as x approaches 1. As x approaches 1. Now, when x approaches, if by direct substitution, we are made to realize that this will give us what? 1, right? So let's still use x is y is equal to 1 line. Can you see? As x approaches 1 from here, okay, there is a jump, but it comes back. So as you are moving close, it's moving close to 1. Can you see that? Then also, as x approaches 1 from here, up, it's also moving. So the two-sided limits coincide. And the value they converge to, we say they converge to that number, both of them. They meet there. You're coming from here, someone is coming from here, you all converge to this class. So this is your point of convergence. If the point of convergence is the same, then the two-sided limits are equal, right? Which means the limit at that point, as x approaches that point, exists, and it's equal to that value. Does that make sense? Finally, let's look at the one you did for homework. This is as x approaches what? Infinity. Okay, so let's remove this. As x approaches infinity from anywhere, maybe from here. Okay, you can go to infinity on both sides. Okay, as x approaches infinity from above, well, infinity is even an above, anyway. So let's look at it from here. It's going towards infinity. What does this do? It keeps going up. So this approaches infinity plus. Are you getting it? So when you say x approaches infinity and you put plus, it means become large. Like that. Okay? This goes up. If you go down, this goes down. So that's why the limit does not exist. And the symbol of does not exist is that infinity you have to get. That's the last question from last lesson. So this is the reason you cannot work that out. Okay? So if you want to write it properly, let's take the last 5 minutes to write the better explanation properly. One, limits as x tends to 1 of 1 over x. So you just write. You've listened to me already. Hello, listen. One other key clue. You are doing this in exam. That's why you have your graphic display calculator. You do a sketch. And you can explain better because you can see the sketch. That's why you have your graphic display calculator. Can you see this? Since the limit as x approaches 1 from below is 1. So if you want to really show more whatever, you can put maybe y is equal to 1 here. And let us see x is equal to 1. Oh, actually, coming from here, it's going to be approaching 1. Coming from here is approaching 1. So that's the reason for this explanation. Okay?
1 to the negative side, you get twice because
Oh no, that means I have a
equals
duty.
to whatever this is, right? Let's say substitution. So for x approaches 1 from positive side. Negative. This is like negative. Yeah. The positive negative is like 1. So you go like this. So that's why you will have this. Get it? Okay, just think. That's the meat.
You didn't wave back. I'm in trouble right now.
And you start to get this.
Look, this is another way you could say this. Guys, this is another way you could say this. If you don't want to write like this, you can write it as x approaches infinity plus. This function approaches positive infinity.
Wait, so that's the same as the limit?
It's the same, yeah. This simply means when x approaches this function approaches 1. That's the meaning. Okay, stretching time. I'll take the picture. Go now. Mr. Londos, you're here.
Mr. Daniel, I already took the left side.
So if I write, I'll take a picture. I'll send to you. Please go. Mr. Londos, you're here. Go, guys. Please, go.